All right, so this video I'm going to talk a little bit about just a couple of quick examples of how time value money works and kind of why and what's going on there. So let's just kind of look at this first example I have here, which is $1,000 invested for 40 years. And what I have listed here is different interest rates being used for the investment. And so at 5%, we wind up with about $7,000 after about 40 years. 10, it's over 45,000. 15, over 267,000. 20, almost 1.5 million. 25%, over 7.5 million. 30%, we're over $36 million, right? So if you look at that, you're thinking, well, what is going on with this? Well, so the reason why I'm kind of drawing attention to this is notice that this is very nonlinear. So in this case, I doubled the interest rate, far more than doubled the outcome. In this case, I increased the interest rate by a third, but I mean, I've just dramatically increased the outcome. And the reason why we're getting such a big shift here is basically because the interest rate or that's involved in the time value money calculation shows up in the equation as something that is raised to an exponent. Okay, so I'm going to back up here slightly and kind of show you that. So if I'm calculating future value, this is kind of something I showed in a prior video. So if I'm calculating future value, notice that the rate here is inside the parentheses, which are raised to this exponent. And so what that means is relatively small changes to that rate, because they're in the parentheses raised to the exponent, it makes a big difference. So a small little shift in that interest rate is going to wind up being raised to this exponent. And so it's going to produce a big shift. So the length, the rate actually makes a very big difference. Okay. But also the length of time matters a lot. So notice if I go from 5 years to 10 years, I wind up increasing by, in this case, $100,000 invested at 10%. From 5 years to 10 years, I wind up going up by a little less than $1,000. If I go from 10 to 15, so that's still a gap of 5 years. But in that case, I wind up going up, well, let's see. So that's going to be around 1,500, 1,600. It's kind of in there. So basically, it's gone up a fair amount. And then if I go from 15 to 20, well, now we're going up by over 2,000, about 2,500-ish, somewhere in there. By the time I go from 25 to 30, I'm going up by almost 7,000, a little shy of 7,000. So 6,500-ish, somewhere in there. So basically, the idea there is, each of these gaps is 5 years, but the amount is quite a bit different. And basically, what I'm drawing your attention to here is that what's happening is as time progresses, there is more interest that's been earned. And then if this is compounding, there's more interest on the interest. And then eventually you get interest on the interest on the interest, and interest on the interest on the interest on the interest, and so on and so forth. And so basically, the longer this continues, the longer this, or the larger the number starts to turn into. And so the length of time matters quite a bit. And so even adding one extra year can be a meaningful amount. And something that to kind of drive home sort of what's causing this, notice if I go back that the length of time is appearing in the formula in the exponent. So it doesn't take necessarily a huge shift in the length of time to create a very substantially different outcome. So going back to this, the difference between saving for 25 years and 30 years, well, I mean, that's somewhere around 60 some odd% higher just by adding an extra 5 years, basically. So because the length of time shows up as an exponent, it makes a big difference. So when you're doing time value money calculations, it's kind of worth kind of keeping in mind relatively modest changes in the interest rate are a big deal. And relatively small changes in the length of time can also be a very big deal. So from an application standpoint, if you were, say, saving for retirement, what you want to do is the sooner you can save, so the more time you have, the better, right? And obviously, if we can get a better rate, that sounds good too. We also need to make sure we're not taking on undue risks, right? So we always have to look at risk relative to reward in finance and make sure that we're getting enough reward relative to the risks, okay? As a little side note, since I can't resist pointing this out, if somebody offers to give you a really high rate of return in a short period of time, we're going to give you 50% return in 6 months or something, or we're going to double your money in the next year. My normal recommendation for that would be run away as fast as you can and hang on to your wallet or purse while you do it. Because it generally speaking, you don't get something that's that high of a return that fast just in general, right? So typically that's one of the hallmarks you typically see of scams, basically, where they kind of entice people in with unreasonably high expectations of return. So obviously, we want to be focusing on return because subtle differences in return matter, but also the length of time matters a lot. And so I just kind of want to show these examples of how it can produce some dramatically different results overall. So hopefully that clarifies some things a little bit and helps you kind of understand how things work a little. Thank you so much for watching and have a great day.